A couple more minutes, get critical mass, and we'll get started. Hi, Ahmad. We'll wait a couple more minutes and then we'll get started.
Hey, good morning. Yep.
Good morning, everyone.
Morning.
Hey, Shab. We'll go to 9:04 and then we'll start. Okay, only because I might lose reception somewhat soon. We can quickly start. So agenda-wise, I believe Ahmad, there was obviously a bunch of discussions we had last week. So I don't know if you had a chance to circle back, and if you have more thoughts or feedback or ideas, that'd be great. And then Shahab, I don't know if I talked to the Boppy a little bit. It sounded like I don't know if you guys planned for you to do an update today or just kind of review of the prior things on optical. But if you're ready for that, then we can do that too.
Sure. I can briefly update and seek for basically what can we do for next step.
Okay, sounds great. Yeah, go ahead, Ahmad.
Yeah, I guess I have some stuff, but I think I wait till Cash, so maybe next time. I think he's traveling, so let's see when he's available. Yeah. I think
Okay.
yeah. So I'll
No
let
problem.
Shahab.
All right. Yeah, I guess Shahab, it's all you then. Shahab, you still there?
Yeah, I'm here, bro. Sorry. Can you hear me now?
Yes, we can.
Okay. Do you want me to go first? Sorry, I thought that.
Yeah, no, Ahmad was saying that he does have some stuff, but he wanted to wait until Kash is back. I guess Kash is traveling today, so we'll probably do that next week.
Okay, let me share my screen. It's gonna be short. I think I talked to Boppy. This is what I basically chat last time. Just to refresh everybody's memory, we have three options basically to pick, at least what I proposed last time. Either we go retime, which is to have another bow RX and do the serialization and then do the E2O and then cover it back to electrical and do the again deserialization, convert it to a bow TX and then communicate with the bow. In this category, we are not changing anything in existing bow. And by the way, we cannot stop people for developing this kind of solution. Then I don't believe that we need to do anything in this format, only maybe one paragraph to just say this option is available. As long as they can maintain the power budget between these two link, then we should be fine. Then the next option was actually going to direct drive with a kind of equalizer and TIA integrated with the chiplet B. And the whole point was to actually maintain 0 dB loss from this edge of the chiplet A to the chiplet of B. Therefore, it's going to be no more pressure on the bow RX and bow TX. And hopefully we can pass the direct drive format like this. And the third one, which I believe everybody rejected and we don't want to go there, is to change the bow and call it optical TX bow or optical receiver bow, which I believe there is no interest on it because we have to include the TIA and we have to define higher speed, higher swing of the driver here. Then we are back to the basically mode 1 and mode 2. And for mode 1, we don't need to say anything as it is already defined in our spec. As the chiplet A and chiplet B is an optical chiplet that supports bow, nothing to do with adding to the bow spec. The only place that we have to say some of the stuff is number 2. And if I want to copy it here to have a better understanding, when I was thinking there are some aspects that we need to communicate. Number 1 is how much we are adding to the latency, how much is the RF loss, how much we are adding to the clock jitter when we are clock forwarding through optical, and how much of the data quality we're going to degrade by adding jitter. I know it's a 0 dB, but jitter is different. And what can we do on the power down? And the 6th point, which I just realized right now, is side channels. Should we support side channels or we go without side channels for this kind of optical? We have to remember any side channels, then we have to dedicate another fiber optic for this type of communication. And I'm looking for someone to basically create a team because I don't want to be alone to basically take a stab on it and try to cover some of this stuff, maybe latency, RF loss, clock jitter, data jitter, power down, and side channel. Maybe a lot, if you can update me a little bit, are we still good with having no side channel on the bow, or we bring back?
So I mean, there's a sideband PHY that is defined, and there's a bunch of definitions around, you know, sort of how to communicate messages and things like that back and forth. You know, on the electrical side.
But can we have the link without sideband?
So it depends on the usage, right? Like, you know, basically for quote unquote normal chiplet things, you know, the assumption is that there's some other way of communicating information anyways, you know, whether it's JTAG or I3C or something like this, and that, you know, in a normal, you know, multi-chip package, that's probably a very good assumption. If somebody's doing something optical, you know, then, you know, that may no longer be true. And I think, you know, at that point, then, you know, having a mechanism for sort of, you know, full on sideband might make a lot more sense. But, you know, again, that's application dependent. So I guess depends a little bit also on you in the sense of, you know, which application do you think you want to try and target this for?
I think any one of the basically major application of the optical is when the chiplets are far from each other. Then considering if they can communicate.
Right. And I guess when we say far, that means, you know, far on the same package. It means
no, far
on the
in,
same board. It means far on,
in the system. Usually we really like to go a couple of meters.
Okay. Yeah. Right. No, exactly. So I think if that's the case, then, you know, it's not that it's impossible to have some other electrical sideband there, but that might be logistically a lot more annoying for people.
Yeah. Then how many sidebands that we are talking about right now? As a minimum, then we can actually have some.
I mean, I think minimum is you just need, you know, you need a data line in one direction and a data line in the other, right? That's kind of the minimum. You know, most likely you're gonna have a forwarding clock along with it. You know, whether or not you spend 4 fibers or 4 wavelengths or whatever is maybe a different question. But yeah, I mean, I think you need some sort of bidirectional data transfer.
So you mean on top of the 16 lane of the data, we need 8 more sideband or 1 sideband for every 8?
No, it would be, in the worst case, it would be 4 more sideband things. You know, a clock, a data, and transmit, and a clock.
And the clock is different from the forwarded clock of the bow?
The idea is the sideband is much lower data rate.
Mm-hmm.
Right, because basically it has to be up without any training or anything. So that's why there's usually a separate thing. And I'm going to lose connection in a second, but please keep going.
Okay, sure. I think that could be a little bit of difficult for optics. I think if we can somehow combine those data to a maybe higher speed or something like that might be more beneficial for optical links.
Yeah, I mean, whether it's separate fibers or not, it's more.
I think
Right.
I think you gave us some heads up that your connection may get dropping. I think we are kind of lost Ilab. At least I cannot hear him.
Yeah, that's what it sounds like.
Yeah. Okay, yeah, the whole I think point is that we have to work a little bit on the side channels. I think this is the same issue that other standards also have when it gets to the optical link. Preferably, we don't want to have any sidebands or side channels or minimize that number as much as possible. And the rest is going to be basically latency and clock and data jitter quality that we are passing through the receiver of the book. And I'm looking for, I don't want to be basically only one person to do this optical. If you guys know anyone or any interest that we can create a basically sub team and start working on modeling and come up with some of the requirement of the clock jitter, data jitter, and how we can minimize the side channel as much as possible, that would be great.
I wouldn't know if anybody within Unlock devices that like would have the background or like even the interest to work on this. So yeah, don't know anybody, sorry.
Sorry, I joined late. I have a quick question on this. So what kind of optical length are we targeting here? I mean, what kind of latencies are we planning to support?
I think the latency is not that high, except depends, the major latency comes from the time of flight, usually in the optics, and time of flight is how long is this cables. And that's why we should be worried a little bit about basically, because we are doing clock forwarding, then the latency, because accumulated jitter might be issue. That's why we have this 6 item that we need to go and do a little bit more details analysis to find out the correct requirement for this type of link.
So are we also forwarding the clock through the optical network?
Correct.
Or okay.
At least that's what I'm thinking to do. I think it's the most easy way to do that. Otherwise, we need to actually recover the clock and have basically CDR at the chiplet B, which is not a good option to have. Do you have a different view, Ram, or?
Yeah, I mean the kind of optical that I have worked on does have a CDR, and yeah, the interface basically gets cut at the optical. So the block that you show with EQ, DR, and E2O, I think that's where I think the interface, the bow, not the bow, but the previous protocol that I worked on, that gets cut on the optical side, and then we completely transmit optical, and then on the other side we recover the clock. But yeah, I'm not aware of how this clock forwarding scheme would work, and that's the reason why I asked what's the length, optical channel length are we targeting here? Because the longer the length, I think it's more going to be more difficult to.
Exactly, because of the latency and
Right. And then the
But,
other problem
I think
is
let me understand. You're referring then to this kind of architecture to just have basically both RX serializer E2 and have basically a deserializer SerDes here, generate the clock here again, and just push it to the Bo RX.
correct. I mean, I've worked more on such concept, not BOW, but a different protocol, but a similar concept. Because I mean, back in the day, I think we got our optical the optical IPs from a different vendor.
Mhm.
Who had the complete interface block like you show as triplet A in this block diagram. So that's the reason why we went that way. But yeah, I mean the other format that you showed may also work equally good. But in either case, I think there are other considerations for latency and like how and whether the BOW needs a larger replay buffers if replay is expected to be supported. So I think from a BOW perspective, I think the latency is probably going to govern what additional features we want to put in the BOW to support longer links.
I kind of agree, but that's why, because to relax that latency a little bit, that's why I was thinking to do the clock forwarding. By the way, there was one paper on the European Optical Conference, ECOC 2023 by NVIDIA, which they try clock forwarding over optical. And they demonstrate how beneficial it is if you do that. But I'm 100% agree. I think this solution exists, and if anybody wants to implement it this way as a retime version or retime form that I mentioned, we cannot stop them basically, and this is the perfect match for any kind of electrical PHY. And this is based on a bow, and it's become a chiplet, but the power consumption is going to be higher, the chiplet area is going to be larger, and if you want to go more on the slightly better power consumption and a smaller area, the direct drive, which is also right now considered by other standards like OIF, can actually come to the play, but that's the place that we need to work a little bit hard to spec it in terms of, as I mentioned, latency, RF loss, clock and data performance, and the possibility of the power down, because if you power it down, you're going to lose basically some of the stuff. And the most challenging one is the sidechain.
Hey, Shab, can you guys hear me again?
Yes, we can.
Okay, yeah, sorry about that. So on the sideband thing, just I don't. Well, okay, I could be wrong. I don't think that's necessarily that bad, at least conceptually, in the sense of, it's as long as it's easy to just get data at some rate back and forth, then that's kind of all the sideband needs to be able to do. I guess the challenge you're referring to is more just physically how many either fibers or wavelengths or et cetera you need to use to actually accommodate for them. Is that your primary concern?
Exactly. The only concern is number of fiber and basically the power that we are burning for those sidechannels. That's it. That's the only issue that I have.
Yeah, I mean, okay, obviously it depends on depends on what the driver is and all kinds of other things. So yeah, but I guess basically I think the main thing with a sideband, and again, this is an application dependent thing. Like, we could just decide that, hey, there's always an electrical connection that people can use to help train the system. But basically that's the primary thing that I think sideband is useful for. Well, I'll be careful. It's potentially useful for training the system. It's also just potentially useful for, hey, if there's any other configuration or setup information centralized and you want to distribute some, kind of like naturally through the same interconnect, that's the other reason you might want the sideband. But like I said, don't get me wrong, like this is not unique to what we're doing here, right? Like there's other systems that people have built that have optical, and they would have the exact same problem that we do. So if generically the community accepted that, you know, when you've got optical, you need some other electrical sector first, that's fine. We can just make the decision.
Yeah, for example, I was looking at a public demo by a company called Light Intelligence, which they do have an optical PCIe. They had the same issue actually. They were using the same channel for basically for their side channels, and they pay for it, you know.
Yeah, well, so I mean, PCIe in principle, PCIe in principle is supposed to be set up in a way that you actually can boot through PCIe, right? So I'm sort of, you know, not surprised that they went that way, but I guess just to be clear, that's doesn't necessarily require a sideband per se, but it, you know, it does definitely have a lot of implications on how sort of the system has to be constructed, and you know, arguably it does go down into touching the PHY, because now you need to sort of start in a mode that guarantees that everyone can talk to each other and negotiate rates and so on and so forth.
100%.
You see what I mean?
I mean, anyway, these are the area that I think we need to spend a little bit time on it, and I don't believe it's either a good idea or even I do have a bandwidth to do all of them. I'm looking for other people who have interest on optical bow to create at least a sub group or something like that to work on all this aspect. And to be more clear on the clock jitter and data jitter, it's going to get back again to one of the tasks that I think you and I will chat about it over a year. If we do have a link simulator, it also helps to model basically the optical component in it and realize how much clock basically and data performance degradation we can push towards the optical environment.
So one question, I mean, or maybe one suggestion, I should say. I mean, to the extent that, you know, there's a believable linear model for the optical sort of, you know, even honestly the electrical, you know, the electrical part that then, you know, converts to optical and back. If you know, if that can just be all converted into S parameters, then you know, we can simulate that right now. I guess the primary sort of question there is just whether or not, you know, it is a believably linear thing or not.
I think it's a really good start if we assume it's a linear, but both of us, we know that this is not a linear system at all.
Right.
And that's where the S parameters modeling is gonna be a challenging or not so accurate.
Yeah, I mean, is there any, do the optical folks have some, because you know, once you're nonlinear, you know, life gets really painful for analysis, you know, at least at very low error rates where you can't just simulate it. So is there is there something out there that the optical community is already making use of, or everyone's just baking their own stuff?
It's pretty much everybody picking their own stuff, honestly, but all of them are going to be in time domain instead of being in S parameters though.
Right, but and I guess just to clarify, are they doing any sort of like they're not relying on pulse responses or whatever, they're just simulating down to some error rate and then extrapolating?
Exactly.
Okay, got it.
But definitely we can try with the linear version first and get some understanding.
Right. I mean, honestly, I think that part is quote unquote easy in the sense of what it'll basically just translate to is, okay, here's how much kind of like, you know, at minimum random voltage error, you know, improvement you need in the bow receiver, given that, you know, the optical piece has taken some chunk of it. And effectively, here's how much, you know, sort of better you need to be in terms of both deterministic and random jitter, you know, once again, to just, you know, sort of compensate for whatever it is that the EO and OE part has done to you.
I agree. I think in terms of other people that can help me, I think there are a couple of companies that we can reach out to see if they like to be part of it. You know, IR Labs might be an option. I don't know if they have any interest on Bow. Intel Silicon Photonics team, I know they have some interest on this kind of link, but again, having interest on Bow is another question. Another one is Ranovus and Nubis Communication.
Yep.
these are the 4 companies at least that I think we can add on to this list and ask them for help or be part of this activity. If you guys know any
That makes
others,
sense to me.
please feel free to suggest. Otherwise, I will reach out to them and ask them if they have any interest to join.
Yeah, I mean, I think you hit the obvious. I guess there's light intelligence, maybe light matter. I don't know. I don't know if any of them are specifically looking in this direction, but those are the only other two that I guess come off to my head.
Mm-hmm. I will reach. At least I can reach out to light intelligence. Do you want to try light matters, Elad? If you know anybody there.
I'm trying to. Let me look if I have any good contacts there still.
Okay. Okay, that's all I had then. As one of the action item, at least for us, is to go after these companies and see if they can be part of this sub team and
Yeah, sounds good.
try to write up something. Thanks.
No, thank you, Sean. Earlier today, just one quick thing. Mark, under the assumption that we sort of end up going in some subset of the directions that we were talking about last week, on smaller FIs and so on and so forth. Do you have any interest and or availability in potentially defining the bot for? I think it should hopefully be a fairly simple thing, but
Yes, yeah, I think I would be able to help with this. I think like the direction wise, it's definitely the like all the work I did kind of for the X8. I'm happy to like go back in the spec and kind of cross check what needs to happen, and then from a more technical perspective, if there are questions there, I may be able to pull in other people as need be.
Yeah, so I think the plan is next week. We'll review things along with Ahmad and Kash, and maybe get some further progress on kind of what the roadmap looks like, and then based on that, we'll rope you in.
Yep. So before we go, do we want to separate what we mean by mode, more additional mode, or sort of? I forgot the terminology, but basically the terminologies that Boppy was talking about. So how we want to incorporate things.
Yeah, I guess fair question. How should I say this? My proposal at the moment would be to hold on that until sort of we've gotten the next round of feedback from you guys on sort of directionally where we think this will go. Because it may just become it may become depending on which way we go with that may influence sort of how we actually want to define it.
Got it. Okay. And yeah, so the other thing, I guess, just food for thought. The other option, if we want to send both clocks, basically, if you want to have clocks both ways, what I was thinking would be beneficial, and we can talk about this next week, is rather than having it on the side, it's having them again in the middle, but two set of clocks in the middle. Because again, if at some point we want to do a sort of flex directional 16-bit, having on the side, you can't connect to the normal 16-bit, but having in the middle, it gives you an option to connect to a 16 bits.
Yeah, no, understood.
Yeah.
I guess there's we might be able to do one thing in one case and one in the other for various reasons, but it's a good thought. We should walk
the way I
cases.
think about it, doing it on the side is just a bad solution. It's just for this case, basically, it just crippled us to do anything, pretty much. So yeah. But anyway, we should talk about it next week. I think this is basic.
I have no religion or whatever. I think there. Anyways, yeah, we should go through more detail. That's the right answer.
Yep. Right.
I just want to check since next week is the OCP summit. Is that are there still going to be like the ODSA
Actually, I'm sorry.
meetings?
That's a really good point. Let me double check with Boppy. The answer probably is no, but let me double check with Boppy.
Sounds good. Okay.
Cool. Thank you, everybody.
Thanks. Bye-bye.
Thank you.
Bye-bye.
Bye bye.